Hey guys, Mr. Ing here going over your Chapter 3.1 test. This is the one I call all capitals. Alright, let's go over question number 1. Which equation shifts the graph of the function f of x equals square root of x to the left 5 units? Okay, you have to think of a letter, A, B, that's a B, C, or D. And this is a horizontal shift, so that's a vertical dilation. This is a horizontal dilation, and this one is a vertical shift. And we're looking for a C value that is -5. So if you add up all your letters, not add up all your letters, put all your letters out here like this. And again, we don't need A, B, and D. You're just putting in C equals -5. Now pay attention. C equals a -5. So that means y equals the square root of x minus 5. And that becomes what? +5. And that would be letter choice D. Now, remember my silly phrase, add to x, go west or left, okay? And basically, this silly phrase is right here, adding to x. You're adding to x right there, okay? So that was question number 1. Question number 2 says, if f of x equals x squared, x is greater than 0, which describes the domain of the inverse of f of x, which is the square root of x. Okay, let's just do a quick graph. And here in green is the f of x function. And I'm first going to just do x squared. So I'm going to do in a dotted line here. This is the f of x equals x squared. Okay, what does the x greater than 0 mean? That just means positive numbers. And positive numbers on the x-axis are going towards the right. So I'm going to make this here solid. Okay, basically it's saying it could be any of these values on the x, and then it goes up in y. Okay. Okay, now we have to do the inverse of this, which is, they're telling us it looks like this, okay? If f of x is, then which describes the domain and range. So this is the new graph. There in red, that is the inverse, that notation up there, the -1, is the inverse of x squared, which is square root of x, okay? And basically all they want to know is what's the red domain there. Okay, so remember, domain is going from left to right. This refers to the x-axis, okay? So if you make all these blue lines, again, we're focusing on the red graph here. If I keep going this direction, I don't start on the red graph here until x is equal to 0. And the last thing you touch on that is the arrow, which is going towards positive infinity. So that is my domain, positive infinity. Remember, you always use parentheses, and the only option that has that is D. Now let me go ahead and double check and show you guys what the range is. Okay, range is the y-axis, and I say you go from bottom to top. Okay, so let's go from the bottom to top. Let me use a different color. Let's use blue. Nothing, nothing, nothing. Okay, it touches the graph, and it's touching the graph on the y-axis, which is the range here, at 0. And the last thing it touches is the arrow, which is going towards positive infinity. So the range is also this. The range is also the same thing. That means your output values are from 0 all the way up to infinity, including 0. And so that would only be these 3 options. and the only correct one that has it is D. So for question number 2, the answer is D. Question number 3 here, which expression is equal to the square root of 81x squared y6 z8 for all real numbers x, y, and z? Okay, so I'm going to rewrite this. And remember, there's no number up here, but it's a 2. The index or the root is 2. Okay, now with these, you can do this in a couple ways. You can simplify by the radical. Let me show you that. So I'll do that in blue here. I'll simplify by the radical. So you have 9 times 9. You have x times x. And you have y to the third times y to the third. Because remember, when you have the same base, they are y's, they're exponents you can add together. And then this would be z to the fourth times z to the fourth. Okay? And basically, when you have a pair, when you have 2 of them, they can come out of the house into the scary neighborhood because there's 2 of them, but when you look at them from far away, it's just one number. Okay? So watch as I do that. There's a pair, comes out, x. There's a pair of them, right? Comes out, y to the third. And the last one, z to the fourth. Okay, they can all come out now, so that's a good thing. Now here's the other part that we need, is something called EVO, which stands for even root or degree, which we have. So I'm going to put a check here. V means variables. Variables. So I'm going to underline in black the 3 variables there. Okay, and then the O stands for on the outside, which we just underlined. Are they odd? Okay, are any of these odd? This is an even number, and this one is an odd, and this one's a 1, so that is also odd. Okay, what does that mean? It means that those 2, x and y to the third, are in absolute values. Okay, so which one has a 9 and z to the fourth on the outside? That would be letter choice A. So for question number 3, the answer is A. Question number 4, the relationship between the length of a pendulum. Remember, a pendulum is, I'm playing this game with my kids, is you tie a string to the ceiling, kind of, and on there is a ring. And this ring can kind of go back and forth. And so that's what a pendulum means. It kind of goes back and forth. So the relationship between the length, I'm going to underline this or highlight it, the length of the pendulum, L, that's what the variable L means in feet. Okay, so that's that position right there. Then it tells us the period is called T, and I think T stands for time, which is measured in seconds. That's its units, so that's T. Okay, now we're going to use our reading skills here. To the nearest foot, okay, here's, which one was foot, L or T? Length or time? Well, time is not measured in feet, but here it verifies this, watch this. To the nearest foot, which is the length of the pendulum? So I see a variable, it is L. L is an unknown. Which is the length of the pendulum? Okay, what does that mean? We're solving for L. Get L by itself. Now, this one also verifies it for us with period 8 seconds. Which one is 8 seconds or time? Is it length or time? Well, time is measured in seconds, right? So that means here T equals 8. So let's use all of our information here and just copy out this formula. T equals 2 pi times the square root of length divided by 32. Okay, and all we have to do is just substitute everything we have. So T equals 8. And that's what we talked about, right? We are solving for this L. This L here we need to get by itself. So as a reminder, in PEMDAS, you are going this direction when you need to solve, which means I need to do addition and subtraction first, which I don't have. Now I need to do multiplication and division. So I'm going to multiply or divide both sides by 2 pi because I have multiplication here. 2 divided by 2 is 1. Pi divided by pi is 1. 8 divided by 2 is 4 pi. Okay, to get rid of the radical, it's an exponent. And you need to just locate the index, which is right here. So if I square both sides, you're going to get this. On this side, the power of 2 and the root cancel with the radical sign. And you're just left with L divided by 32. On this side, you get to use something called the power rule, which means that that 2 goes to both of them now. So that'll be 4 squared and pi squared. And I'm actually not going to evaluate now. I'll tell you why in 30 seconds. This is division, so I'm going to multiply both sides by 32. How do you make 32 a fraction? You put over 1 over 1. And so you get 32 divided by 32 is just 1. So you just have L equals 32 times 4 squared all over pi squared. 32 4 squared divided by pi squared. Let's put in our calculator. So I have 32 times 4 squared divided by pi squared. My pi is in yellow above the division sign, so second pi, and then I'm going to square that. 51.876. 51.876. 51.876. And the closest choice that we have there is C. So the answer for number 4 is C. Alright, question number 9 here is telling us which is a solution. So we just have to solve this. How do I know to solve? You always solve equations. So let's go ahead and write this problem here. Notice that positive 4, though, is not inside the radical sign. I like to draw a line down my equal sign to show the left and the right side. I have here PEMDAS. Remember, when you're solving, you're actually going from the bottom to the top. So here I have addition. So I'm going to subtract, or the opposite is subtracting. So I have the cube root of x plus 1 equals negative 4. The next thing I'm going to do is, now that the radical sign is isolated, meaning there is nothing in front or behind this, I'm going to go and identify the root, and I'm going to take the power of 3 to each side. So this cancels, and the radical sign, so you're just left with x plus 1. Over here, this means negative 4 times negative 4 times negative 4. So that's positive 16 times negative 4, so that's going to be negative 64. And if you subtract 1, you will get x equals negative 65, which is choice what? That is choice A. Number 9, the answer is A. Alright, question number 10. How are the graphs of its function and its inverse related? Function and its inverse, okay? Let's just go through the choices and you'll see which one's the correct answer. The graphs are symmetric about the y-axis. So remember, I have a silly phrase for that one. That one's called evenly. You guys remember that? So the symmetry, let's just say we're doing the parabola x squared, and if we're saying that it's symmetric about the y-axis, it's just flipped over. But that's not the inverse. This one's talking about symmetry and folding it in half, so no. Alright, the graphs are symmetric about the x-axis. So again, if you take the same graph we just had above, and now we're saying it's symmetric or reflects over the x-axis, then you're saying the graph is something like this. That one to me looks like more of a transformation, like y equals x squared, and then the second graph looks like negative x squared, where your a value is -1. That would be a transformation, but not that graph, so not that choice. Okay. Identical graphs are kind of just saying you have a limited solutions, right? So if I take the black graph and then the blue graph, how many times do they intersect? Well, there's an infinite amount of those, so this would be like infinite solutions. And it's not that one. So the correct choice, not because the other three are wrong, but I'll explain that. How are graphs of its function and the inverse related? Remember, if we did the graph previously, and then we had, remember, x squared, and then we said, well, just the positive values, so this bolded one here, and then we said, well, if you do all the tricks to it, let's do the trick. So the trick graphically is rotating it 90 degrees counterclockwise, which is to the left. So over here, and then the next one would be reflect it over the y-axis, so that your graph would look like that, right? Which is, if you think about it, this red graph is the inverse, but here's a relationship I'm talking about. It reflects actually over this line here. That line right there is called y equals x, which is called an identity. So the correct choice is C. The answer for number 10 is letter C. Number 12 is asking us to, what is the exponential form? Exponential form just basically means you have an exponent, but more importantly, no radicals. And this, my friends, is a radical. Another way that they are saying what they want from us is rational exponents. Okay, so take a look at this x here. I have it in green. And this 3 becomes its numerator, the top of the fraction. And the yellow part is the index, or the root, which becomes its denominator, the bottom part of the fraction. And there's only one of those, which is A. Now, you don't do anything like flipping. That would be wrong. And there's no negative exponents. So the correct answer for number 12 is A. Number 15 here, which is an extraneous solution? How do I describe an extraneous solution? It's a solution at first, but it's really a fake, because when you do it the second time, it actually makes it false. It's an imposter. It looks like one, but it's not really. Let's try this problem. X plus the square root of x equals 6. Alright, we've always talked about isolating the variable we're trying to solve for. So I'm going to subtract x from both sides. This gives me 0, and this gives me the square root of x equals 6 minus x. Okay, to get rid of this one, I have to identify, now that the radical sign is isolated, there's nothing in front and there's nothing behind it, then I can just locate its index, which is a 2, or the root is 2. What that means is I can just square both sides. This 2, and the radical sign are gone, so you have x equals 6 minus x. You really have 2 of those, right? So let's go ahead and multiply. I'm just using FOIL. Multiply, then add 36, negative 6x, negative 6x, positive x squared. Okay, so we multiplied, and now we're going to combine like terms or add. So this would give me x squared minus 12x plus 36. To solve quadratics, we're going to have to get this equal to 0. So this gives me 0 equals x squared minus 13x plus 36. I'm hoping that all of this can be factored. So let's see if we can factor that. A, B, and C. A times C is 36. B value is negative 13. What numbers multiply to be 36 but add to be negative 13? Can you locate any of those? Right there. So 9 and 4 both are negative. Negative 9 times negative 4 equals 36, and negative 9 plus negative 4 equals a negative 13. So we have factored okay. Because we factored, now you can just solve these by setting them equal to 0. And you'll get x equals 9 and x equals 4. Okay, so let's be careful here. Just let me highlight these. These two are my first solutions, and now I'm trying to find a fake. How do you find a fake? Well, you check your answer. Let's check our answer. Whoa, whoa, whoa. Check. So x plus the square root of x equals 6. Let's do this one in a different color, 4. Okay, so let's see what happens. And let's do that. Let's put in 9 here. Nine plus square root of 9 is 3. And what does that mean? 12 equals 6? No, so this is our extraneous. Let's double check. Right, does that make sense? It's a fake. We made it false. Let's put in 4 here. 6 equals 6. That is true. So the real solution is x equals 4. X equals 9 is our extraneous. Let me do that in red. Right? Red. So that would be D. 15. D is our answer, is extraneous. Number 17. Which type of transformation or transformations transform the graph from f of x into the graph of f prime of x, which is just the inverse. And you have all this stuff going on. So again, that just means inverse. Or a graph moved. So if I have this graph, a times the cube root of bx minus c plus d. Alright, so let's just look at the letters we have here. I have this a value, and this is a vertical stretch. How do I know it is a stretch? It's because the number is bigger than 1. If it's smaller than 1, like 1/2 or 1/3, it would be something called a compression. So that is the A value. Now, there is nothing on the inside to the left here. That would be a B value, so we don't need that. There is no value out here, so there is no D value, but we do have a C value. Now pay attention, I'm going to do this very slowly. C, do you see how the formula has a minus sign? So C equals 2. We call this a horizontal translation. And because it's positive, it's actually going to go towards the right too. So let's see what we have over here. Horizontal shift, that's good enough. A vertical compression would be a number less than 1. We just talked about that, so not this one. And a vertical shift would be a D value, but we didn't have a D value, so not that. So that is your answer for 17. It's either A or D. Alright, for number 18 says, which points do the graphs of the functions f of x equals x cubed and its inverse cube root of x have in common? Alright, so let's just go ahead and get some table of values here. And the first thing I'm going to do is I'm just going to change the f of x into a y. Okay, and what we can do here is just make a table. And yeah. So if I make something like, if you look at all of our x values here, they pick some strategic ones. So let's go ahead and do that. Let's put in -2. -2 would be, -2 cubed would be -8. So 2 -8. Let's try -1. -1 cubed would be 1. So -1 comma 1 would be your other order pair. Let's put in 1 here. That would also be a, whoops, that was supposed to be a -1. And last one is 3. If you put in 3 cubed, you get what? 27. Alright, let's do the same thing over on this side. But here, we're going to do what? F of x, or its inverse. And again, just change that to a y. And the numbers we need to do are -2, -1, 1, and 3. Okay, so if you put in a cube root of -2, there are no 3 identical numbers that multiply to be -2. So that would actually be your answer. If you put in -1, are there 3 identical numbers that multiply to be -1? And the answer is yes, it is what? -1. How about 1? Yes, it's what? 1. And how about 3? Can you think of 3 identical numbers that multiply to be 3? There are none, so this would be your answer. Okay, so let's take a look at what we have here. Okay, -1, -1. -1, -1. That matches. So B. And look at that one. 1, 1. 1, 1. So your choices are either for number 18 are B or C. Alright, which pairs of functions are inverses of one another? If you recognize what we have here are 2 function notations. And basically if you, like for A, you put F into G and then G into F and then the same thing, then essentially what you get is they are inverses. Okay, so let's go ahead and separate these. And maybe we'll do this one in red. and I'm going to do f into g. So we're going to put g in for f. So the f function is x squared plus 1, but every x value now, we are putting in a g, which is x squared minus 1. And what does that mean? You have 2 of those, so all we have to do is just multiply those out and add 1. Let's do that over here. We're going to multiply, then we're going to combine like terms. So x to the 4th, negative 1x squared, negative 1x squared, positive 1. So combine like terms, you get x to the 4th minus 2x squared plus 1, and then you also have that plus 1. So our final answer is going to be x to the 4th minus 2x squared plus 2. Okay, let's see if it works the other way now, where if I put into my function g, so instead of putting in x, I'm going to put in the f of x. So g is, watch this, x squared minus 1. And now I'm going to put in, instead of x, whoops, this was my highlighter, x, we are now putting in x squared plus 1. X squared plus 1. Do you see how that's your f value? And then that'll be squared minus 1. So we have to do the same thing over here. Let's do it. And we have 2 of those, so we're going to multiply and then combine like terms. X to the 4th, 1x squared plus 1. And that would give us x to the 4th plus 2x squared plus 1 minus 1, and then these would equal 0, so you're just left with x to the 4th plus 2x squared. And those are not equal, which means these are not inverses. Okay, and we get the wonderful privilege of doing that 4 times. So let's go ahead and do B now. Let's do the screen one. Every h value we're going to put in k of x. Okay, so my h value is x squared plus 3. But for the k of x up here, we're going to do square root of x minus 3. Okay, this is good because cancels, the 2 up here cancels, and the radical sign, so x minus 3 plus 3. And then these would cancel and you'd be left with just x. Okay, let's do the same thing now, but we're going to do k of x. But every x value in k, we're going to put now the h. So here is k. K is square root of x minus 3. And for that k value now, I'm sorry, the x value, I'm going to put in the h of x, which is x squared plus 3. Now you still have that minus 3. Do you see that? Okay. Positive 3, negative 3 equals 0, and these also cancel. So you're just left with x. What does this mean? This one is a good thing. They are inverses by composition. So green works. Let's highlight that. Okay, let's go ahead and try now C. Let's use blue. P of x, and we're going to put in Q of x. P of x is x cubed minus 2. And Q of x, this x value, is x to the 1/3 minus 2. X to the 1/3 minus 2. And you have to the power of 3 here. Minus 2. Okay, this one's not going to be fun. Because, let me double check. Yeah, we have to do that 3 times. Oh, boo, boo, boo. Right, x to the 1/3 minus 2, x to the 1/3 minus 2. Okay, remember, same base, you add the exponents. So this becomes x to the 2/3, negative 2x to the 1/3, negative 2x to the 1/3, minus 2. So this would become x to the 2/3. Combining like terms, you just add the numbers in front. And we have to do it one more time. Alright, multiplying the same base, you can add the exponents, so that will give you x to the 3/3, 1/3 plus 2/3, or 1 plus 2 is 3, so 3/3. Negative 4, same base, add the exponent, so 1/3 plus 1/3 gives you 2/3, and this will give you negative 2x to the 1/3. Negative 2x to the 2/3, 8 to the x to the 1/3, and positive 4. Okay, so here's the tricky part. All of this will be our answer. So x to the 3 divided by 3 is just x. I have negative 6x to the 2/3. I did that by combining these two. So this one, this one, this one. 8 minus 2 is going to be 6. So 6 to the 1/3 plus 4. And then you have that minus 2 on the outside. So x minus 6x to the 2/3 plus 6x to the 1/3 plus 2. And I doubt the other one's going to look that complicated, but we're going to try. So let's see what happens. Q of x, we're going to put in p of x. So Q is x to the 1/3 minus 2. And p of x is x to the 3rd minus 2. X to the 3rd minus 2. Let's double check. Yes, and Q we put into P, P we're putting into a 1/3. Okay. Put that as a minus 2, and then you can just change this into radical form, might help. That's the index. And then this is the root. Now that minus 2 is on the outside. So those you cannot simplify. So question, does this one look like that one? The answer would be no. So not C. Let's look at D. We have R going into S, and then S we're going to put in R. If it works both ways, then it is an inverse. So r is x plus 3 plus 2. And the x we're putting in there is 2x minus 3. Cancels, cancels. 2x over 2. And that equals x. Okay, this one looks good. Alright, over here, s is 2x minus 3. And this x value is x plus 3 over 2. Okay, what does that mean? Multiply by 2 minus 3. Here, cancel these factors. You're left with x plus 3 minus 3. And that one equals x. X. Good. Which means that D works. So our answers are either B or D for number 20. Hopefully that was helpful. See you guys.